Hello, my name's Gabe. For this problem, we're given the function f of x equals 1 divided by 3x plus 1, and we're asked to show that it's 1-to-1 on its entire domain, and therefore has an inverse function. So what I've done is I've gone ahead and I've sketched the graph of the function, and the first thing that I want to look at is I want to ask myself, does this function pass the horizontal line test? So looking at this function, we see that if I draw any horizontal line, it'll intercept the graph at most once. So you can go up a little bit and come all the way down, and you'll see that any of these horizontal lines only intercept the graph at most once. So now what we want to do is to show that f has an inverse function, is we want to start by assuming that f of x1 is equal to f of x2. Where x1 and x2 may or may not be the same number. And if they do end up being the same number, then we can say that this function is 1-to-1 and has an inverse function. So let's go ahead and plug x1 into our function. That'll give us 1 divided by 3x1 plus 1. And if we substitute x2 into our function, we'll have 1 divided by 3x2 plus 1. Now from here, there's many different ways to try to solve for x1 or x2. Let's actually start by cross-multiplying. So we can multiply this one by 3x2 plus 1, and we'll multiply this one by 3x1 plus 1. So now we can subtract 1 from both sides of the equation, and that leaves us with 3x2 equals 3x1. Now we can divide both sides of the equation by 3. And that leaves us with x2 equals x1. So since we started by assuming that f of x1 was equal to f of x2, and we were able to show that this implies that x1 is equal to x2, this means our function f is 1-to-1 and therefore has an inverse function. Thank you.